So today we will study AVL Tree. In our last lesson, we learned how to use BFS and DFS traversal algorithms to traverse a binary tree. So today we study AVL. AVL is also actually a binary search tree, but here is a key point that it says self-balancing binary search tree. So let's see a little details about AVL. AVL, it is the name of the inventors. There are two scientists that worked on this, Adelson-Velsky and Landis, and they invented this in 1962. Wow, which is quite old and most probably older than all of us. So there are some more details. You can read them for yourself. But at this point, the whole point is that it is a self-balancing binary search tree. See this binary search tree. Generally, binary search tree is a kind of binary tree that every node is bigger than its left child and smaller than its right child. For example, in this example, number 30 is bigger than its left child, smaller than its right child, or this one. Bigger than the left child, smaller than the right child, if there was a right child. And or this one. Bigger than the left child if there was one, and smaller than the right child. You see, they are all examples of binary search tree. One of the major drawback about binary search tree is that sometimes it gets skewed too much, either to the left or to the right. And right now, these two examples, they look exactly like a linked list. And the complexity is On here. For example, if you check number 10 here, you need to check all the nodes and come here. So like after 1, 2, 3, 4, after 5 comparison, you can find your key. Or here, for example, if you check number 50, after 3 times you can get this. But here, after 1, 2, 3, 4, 5, after 5 comparison, you can find your key. So this is actually the reason why we are studying AVL, because AVL is a balanced binary search tree. And when we come across any skewed binary search tree, so we need to make it balanced. And that is when we need to learn AVL. So in order to make it balanced, that means we need to rotate this to the right or to the left. And in order to do this, we need to learn something, how AVL works. So when we want to rotate this, there are 4 scenarios that you will come across. Those scenarios can be left-left rotation, right-right, left-right, or right-left. What does that mean? So first, before reading any definition, see how they are illustrated here. That makes your job much easier. So generally, when you look at these pictures, when your binary search tree is skewed to the right or skewed to the left, so you need to rotate this to the opposite side. For example, this one is skewed to the right, or we can say it is right heavy. So in order to make it balance, you need to rotate this to the left side. Or this one, which is skewed to the left or left heavy, so we need to rotate this to the right to make it a balanced tree. So, and in order to do that, we need to know the height of every node. And the height of every node is the number of edges on the longest path from that node down to leaf. So, for example, this one. What is the height of this node? So there are 2 subtrees, and we need to find the longest path. Actually here, so 1 edge, 2 edge, 1 edge, 2 edge, 1h, 2h. So the longest, they are all equal, which are 2. So the height of this node is 2, or the height of this node. So we need to find the longest path up to the leaf. So there is actually only one path. So 1, 2, 3, 4. The height of this node is 4. How about the height of this node? The height of this node, so again there is only one path to the leaf. So 1, 2. The height of this node is 2. And you also should know that a leaf node has a height of 0. For example, this one, this one, this one, this one, they have a height of 0. And an empty node has a height of -1. For example, this node, it doesn't have a right child. So if you need to check the height of its right side, you give the default value of -1. So, and how do you know if it is not balanced? So you check the balance factor. The balance factor means the difference between the height of left subtree and right subtree, and that difference should be within this range. Like a balanced subtree can have the most difference of only 1. So the value can be -1, 0, or +1. If the result of this calculation is out of this range, that means that binary search tree is not balanced. And in order to balance that, so you need to make some rotations. And on any node that you found imbalanced, you consider 2 nodes after that, how they are inserted or deleted. Based on how they are inserted or deleted, you are doing your rotation. If the 2 other nodes after that node that you found which is imbalanced are both inserted to the left side, that means like left, like this example. For example, at this point, you found that it is imbalanced, so you take 2 nodes after this, and you see both of them are inserted to the left side. So that is why it is called left rotation. So, and generally, based on the picture, if any tree is left heavy or skewed to the left, that means you need to rotate this to the right, or right rotation. That means both of the node inserted to the right side, like this example. So you, for example, you calculated the height of this one. Let's calculate the height of this and see how that works. So the height of this, so you need to see the height of left subtree. So you don't see any left subtree. So the default of empty node, I said there is -1. So we gave it the -1 value, and then minus height of right subtree. So right subtree, the height of right subtree is only 1. So you give it 1, and 1 minus 1 is -2. So you see that it is out of this range. So that means it is not balanced. And now, as soon as you found a node which was imbalanced, you check 2 other nodes, how they are inserted, and both of them are inserted to the right side. Or sometimes it can be left right or right left. For example, this one here, you see it is left right, like the immediately after node is inserted to the left side, and after that inserted to the right side. That is why we call it left right. Or this one, right left. So you found it was imbalanced, and then when you check 2 other nodes, it is inserted to the right, and this one is inserted to the left. So that is why it is called RL, or right left. So when you are doing your rotation, generally you only need to consider 3 nodes. Like, so regardless of how many nodes exist in that tree, you check only 3 and do your rotations. So for example, this one, it is left heavy, so you need to rotate this to the right side. And when you rotate this one to the right side, it becomes something like this. Let me have a copy of this. I think it can help us. Yeah, something like this. So when you rotate this, that means you take number 30 down and 20 becomes the root. So number 30 becomes down, it becomes the right child, and 10 stays in the left child. See, when you rotate this to the right, it is changed to this form, and now it is a balanced tree, binary search tree, and now it is called AVL tree. We rotate this to the right because it was skewed to the left side, or it was a heavy left tree. And if it is right like this, if it is skewed to the right, both of those nodes are inserted to the right side, we need to rotate this to the left side, as you see in the picture. It makes only sense that you need to rotate this to the left side to make that balanced. You make like this. You take number 10 and move it down so that 20 becomes the root, like this. Let me make a copy of this again. Okay, so when you take number 10 down, it comes here, number 20 stays there, and number 30 comes here. So now you see it is balanced tree. How about left right, like this? So when it is left right or right left, you need three steps. So, and you start rotation from the most sub tree. For example, first you check this one is like right heavy or skewed to the right, so you rotate this part to the left like this. And when you rotate this to the left, it becomes like this. So let me have a copy of this one, for example. It can help me. So when you take this part and rotate this, that means number 10 comes down and number 20 comes here. It becomes something like this. So you take number 10 down, number 10 comes here, and number 20 comes here. So number 30 is staying at its place. See, you rotated only this part, and when you rotate it this, it becomes like this. Now it is like left, like both are inserted to the left side. And at this point, you rotate this to the right. So when you rotate this to the right, let me have a copy of this. It becomes something like this. So when you rotate this to the right, that means you take number 30 down, and 20 becomes your root, and 10 stays there, something like this. See? So if left and right are mixed, that means you need 2 steps. Or for example with this one, which is right left. So again you start from the most sub tree. So first you need to check this part, which is skewed to the left. Then you need to rotate this part to the right, like this. So if you rotate this, there it becomes something like this. Let me have a copy of this one. duplicate. So when you rotate this port, that means you are taking number 30 down and 20 comes here. So number 30 comes here and number 20 comes here, something exactly like this. See, you are rotating only this part, and when you rotate this part, it becomes like this. And now when you see, it is exactly like this. So you now rotate this to the left side, something like this. And when you rotate this, that means you take number 10 down and 20 becomes your root, and 10 becomes the left child, 30 becomes the right child, for example. So let me have a copy of this, and it can something like this. So when you take number 10 down, so it becomes the left, and 20 becomes the root. So always when you need to learn how to rotate, first you learn them in picture, visualize them. As soon as you visualize that, you know what does it mean. Otherwise, like, you cannot learn what does left mean, because you see these terms in a lot of resources. So it is the easiest way to visualize them, and when you visualize that, that is easy and you can learn it much faster. So these are the main methods that we need to develop in order to complete these operations. For example, for rotating left or for rotating right, we need to develop methods for each of them. So right rotate or left rotate. Get balance, we need to check the balance factor of every node. So if it was out of this range, we can identify if it is balanced or not, and we need to get the height of every node. So, and we need to insert new nodes. So these are the main methods that we need to learn them, and we will learn them in the next lesson, because right now if I develop all these methods, this video would become very long and it would be very tiring to listen to all of them. So I hope you have learned the concept of like all these rotations and balance factor and height. So to briefly summarize AVL tree, AVL tree is a self-balancing binary search tree. So first you should know that it's a binary search tree, but the difference with the binary search tree is that it is balanced. Binary search tree has that major drawbacks, which it can be skewed. So after that, you should know the height of every node, and you should know the balance factor, and the balance factor should have this value. If you found a balance factor out of this range, that is the point that you know it is not balanced, and then you need to start rotations. And now you know how to do all the rotations. There are generally 4 scenarios, and you develop those 4 scenarios based on how the 2 other nodes are inserted after the node that you found which was imbalanced. So no matter how your tree is large or small, you only consider 3 nodes. For example, sometimes your tree can be large, so you only take care of 3 nodes and make your rotation. Other nodes stay at their position. So until the next lesson, have a nice time. In the next lesson we will develop all these methods, but right now you should learn visually that what does LL rotation mean, right notation, left right, and right left. So when it is mixed left right and right left, that means you need to have 2 steps, and in 2 steps rotation you can make it a balanced binary search tree. And when you make it balanced, that means that is AVL tree. Until the next lesson, have a nice time, everyone.